For today's lesson, we will be discussing about correlational analysis. In this video, we will discuss how to apply correlation analysis whenever we have two variables. So before we proceed with that, let's discuss first the two kinds of data that we have. So the two kinds of data that we have is what we call as the univariate data, and the other one is the bivariate data. When we say univariate data, it is a data which involves a single variable only. So if you only have one variable in your study, then that is called a univariate data. For example, you just want to identify the height of your sample. So that involves one variable only, which is the height. Now for bivariate data, it is a data which involves two variables. So for example, you want to identify the height and weight of your sample. So that involves two variables because you're trying to identify the height and the weight. Now, if our data involves two variables, we use the correlation analysis. So what is this? It is the process or procedure of describing the relationship between two variables. So let's say you have two variables and you want to identify or describe the relationship that exists between these two variables. So we use correlation analysis. So this is finding how the two variables are related with one another, or describing what relationship exists between the variables that we have. So we have what we call as the scatter plot. So it is a graphical representation of the strength and direction F correlation between two variables. So we use the scatter plot to show graphically how our variables are related with one another. So later I will be showing you some examples of a scatter plot. And we also have what we call as the trend line. So it is the line that the points on the scatter plot tend to follow. So after you plot your points in the scatter plot, you will see, or you can observe, that your points they tend to follow this trend line. Sometimes they don't follow a particular line, so you will see later on. The relationship between two variables is described in terms of strength and direction. So these are the two things that we have to consider whenever we're identifying relationship between our variables. So we describe them in terms of strength and direction. So let's discuss first the types of correlation when it comes to direction. So we have three. First is a positive correlation, we have negative correlation, and zero correlation. So for positive correlation, high values in one variable are associated with high values in another variable. We can also refer to this as our variables having direct proportion. As one value increases, the other value increases, or high values in your variable is associated with the high values of another variable. So for example, the increase in the number of customers is associated with the profit or the high profit of our restaurant, or vice versa. So that is an example of a positive correlation. Another one, longer, or the time of exercise, or the time you spent exercising, and the calories that you burn. So the number of calories that you burn is associated with the time that you exercise. So if you want to burn more calories, so you have to exercise longer. So that is again an example of a positive correlation. So this is an example of the scatter plot of positive correlation. So as you can see, the points are these points right here. These are the data that we have. So you can plot your data using the X and Y. So as you can see, the points are tend to get closer with one another, and they follow a specific pattern. So if you draw a line here, so as you can see, they follow this line. So this is the trend line, and the points gather around or close to our line. So if it is positive, or if our data shows a positive correlation, so the trend line that they follow rises to the right. Okay, so that is again for positive correlation. Next, for negative correlation, high values in one variable are associated with low values in another variable. So here in this one, you can think of it as having inverse proportion, or as one value increases, the other one decreases. Okay, So for example, so as the speed of the car increases, the time covered to a particular travel decreases. Okay, so that is an example of a negative correlation. Another one, the number of workers and the number of days of finishing a task. So as the number of workers increases, the days of finishing a particular task will decrease because we now have a lot of workers to work with the said task. So again, that's an example of a negative correlation. And for zero correlation, high values in one variable are associated to either high or low values in the other variable. So there's no fixed relation with our variables because high value of one variable can be associated to a high or low values of the other one. So for example, the grade in math and the amount of coffee that you intake for a day. So as you can see, high grades in math is not associated with the amount of coffee, so it means like there's no relationship that exists between the two variables. Or another example, the amount of time that you spend in the internet and your water bill. So again, there's no connection between the two, or there's no relationship that exists. So is considered as zero correlation. And if we're going to plot the data in our scatter plot, so this is how it looks like. So as you can see, in zero correlation, there's no pattern, or our data doesn't follow a particular pattern or a trend line. So there's no specific trend line that they follow, and the data are scattered from one another. So again, these are the three types of correlation based on the direction. Another one is for the strength. So the relationship between the two variables may be perfect. It can be very high, moderately high, low, negligible, or zero. So these are the words that we use in order to describe the relationship between two variables based on the strength. Okay, so before we can identify or determine this terms, so we have to solve for a particular variable first, and we call it as the Pearson product moment correlation coefficient. So the correlation coefficient R is a number which describes the strength and direction of relationship between two variables. So this value of R, or the correlation coefficient R, it is a value wherein it helps us to describe the strength and at the same time the direction of the relationship between our two variables. So this will be our basis in determining the relationship between the variables that we have. Now after solving for the correlation coefficient R, so we just have to look at the scale. So here is an example of a scale that we're going to follow. So if you search in the internet, there's a lot of scales available. It might be different from the one that I'm showing you, but you just have to refer to the one that you're using. So for now, we will be using this interpretation, or this scale. So you have here the value of R, and we have the corresponding interpretation. So the values of the correlation coefficient range from -1 to 1. So the values that we can get from R, or our correlation coefficient, should be from -1 to 1 only. So how are you going to use this table? So let's say the given value of R to you is 0.65. So if it's 0.65, you just have to identify where is 0.65 from the table. So as you can see, 0.65 is here. So it's here. So it is in our high correlation, because the values of R there is positive negative 0.61 to positive negative 0.80. So our R is equal to 0.65, so it falls within this category. So it's high correlation. Now, how are we going to write our interpretation? So aside from this one, we also have to take note of the direction. Since this one is positive, so we have to write here high positive correlation. So this value tells us the strength and also the direction of the correlation or the relationship of the variables that we have. So how are we going to understand this high positive correlation? So what's the degree? At what degree is the correlation between the two variables if r is equal to 0.65? So it has high correlation. And at the same time, since r is positive, so we can say that the direction is positive. So it's a positive correlation. If we combine the two, high positive correlation. Okay? How about if r is negative? So if r is negative, let's say r is equal to 0.4125. Let's say it's 0.4125. So you just have to locate where is 0.4125. Well, let's say this one is negative 0.4125. So it falls within this category. So we can say it's moderately high correlation, but since this is negative, so our interpretation will be moderately high negative correlation. So it's moderately high. And what's the direction? It's negative because r is negative. So moderately high negative correlation. So that is how we use this table. So again, we will refer to this one. So we will be solving for r and we will try to interpret what's the relationship that exists between our variables based on the strength and direction. So by the way, this is the formula that we're using to identify the product moment correlation coefficient r. So as you can see, we have here the x and y. So this refers to the two variables that we have. But for today, we will not be using this formula anymore. So we will be using a particular calculator that will help us to just get directly the formula or the answer or the value of r. Because in reality, whenever we do research, we're just using the calculators and we're not doing it manually. So let me introduce to you one of the sites that we can use in order to get the value of r. Okay, so you can refer to this website. So we have here social science statistics. So this website includes a lot of calculators, not only for the person r, but also for other types of statistics. So you can use this for your research or if you want to compute for a certain value. So here, what we have is this one. So you just have to input the values later on and then calculate r, and then that's it. Our main concern here is to write the interpretation. So you should know how to interpret the value that we have. Okay, so let's try with this example. The following table shows the grades of 5 students in mathematics and English. Determine the correlation coefficient between the two variables. So here we have the grades in math and we have the grades in English. And what we want to know is to determine the correlation coefficient or the r. And then what we will do later on is we will try to write our interpretation. So what you will do is, in the website that I showed you, you just have to input the x, all the values here under x and also for y. So these are our two variables. So you just have to input this and then let's calculate. So let's try. So here, you just have to input the numbers or the data that you have. So for x, we will input here the grades in mathematics. So we have 90, 85, 79, 83, 86. And then for y, we will put here the grades in English. 94, 82, 88, 85, 85. And then after that, you just have to press calculate r. And then just wait. So there. So here we already have the value of r, which is 0.4165. If you scroll it down, so you will see the scatter plot. So here is the scatter plot. It looks like they're following a specific pattern, so we will see later on. So as we can see here, so you have the r, which is 0.415. Actually, you can also see here the interpretation, although technically, So based on the website, although technically a positive correlation, the relationship between your variables is weak. Okay. So the nearer the value is to 0, the weaker the relationship. So let's see. So again, the value is 0.4165. So we have the 0.4165 as our value of R. And if we will look at the table, so let's just go back to the table. So 0.4165, so it falls under moderately high correlation. So let's write here moderately high positive, because R is positive correlation. So if you remember from the website, it says that the correlation is positive, so that's correct. And although there's a correlation, but it's weak, so it's moderately high, so it's not that high. Okay, so that is how we can describe the correlation between the variables that we have. So they have a positive correlation, the grades in math and also the grades in English, but it is weak. Okay, it's not that high. Correlation coefficient and also how to interpret. So let's have another example. It is believed that aptitude is a factor related to the performance of an individual. The following table shows the aptitude scores and performance scores of a group of students. So when we say aptitude, this refers to the skills of the, let's say, the students. And we want to check, or we want to see from this data if aptitude is really a factor related to the performance of the students. So let's solve for the correlation coefficient and let's see what's the relation that exists between the two variables that we have. Okay, so let's input here the values. So for the put here the aptitude scores. So we have 18 plus 16, 15, 14, 13, 12, and 10. And then for the other one is the performance score. So we have 12, 10, 11, 8, 6. And then let's calculate R. So the value of our R is 0.9588. So if you will see here, so there. So this is the scatter plot. So as you can see, our variables are going to the right, upper right here, and they tend to follow a line here. And if we scroll down more, so we will see here, this is a strong positive correlation, which means that high X variable scores go with high Y variable scores and vice versa. So that can be our interpretation here. So we have 0.9588. So we can write here R is equal to 0.9588, which means, again, if you are going to look at the table, so we will get very high positive correlation. So this means that the correlation between the aptitude score and the performance score is very high. So we can say that the aptitude is somehow a factor to the performance scores of the students, and it shows a positive correlation, meaning high values in the aptitude score gives us a high value in the performance score. So it is also very visible here in our data that we have. So again, that is our correlation coefficient. And let's just have one more example. So a researcher would like to determine if there is a correlation between a person's IQ and EQ. The results of 10 students are shown below. Compute the correlation and interpret. So let's try to put these values into our calculator. So let's put the values here. So IQ will go to X values. So 115, 94, 87, 100, 90, 84, 118, 93, and 126. And for the Y values, we will put here the EQ. So we have 91, 116, 121, 104, 120, 126, 86, 121, and 80. Then calculate or let's see. So here we have negative 0.9895. So if we will scroll down, so as you can see here, our points are close to one another, so it's like they are forming a line and they fall to the right. So it really means that we have here a negative correlation, and it is also correct since we have here a negative R value. So you will see here, this is a strong negative correlation, which means that high X variable scores go with low Y variable scores and vice versa. Okay, so again, our R value is 0.9895. So we can write here R is equal to negative 0.9895. And if you will look at the table, that falls to very high correlation. But since it's negative, so we will write very high negative correlation. So there is a correlation, a very high correlation between the IQ and EQ scores of persons. But it is a negative correlation. That means high value in one variable associates with a lower value with the other variable. Because as you can see here, the IQ is 115. The corresponding EQ is 91. Then the next one, we have an IQ of 94. Its corresponding EQ is 116. So, if one variable is high, the other one is low, and vice versa. Okay? So, that's why it's very high negative correlation. So, that's it for today. I hope you learned something about the basics about correlation analysis, and see you next time.